Hey, how's it going? I'm gonna do a video that's very different than what I usually do. For the longest time, I've been using MaxScript and 3ds Max to do my, I guess, like 3D model ripping stuff needs. And I thought I would change it up today, and I tried to use Noesis. So Noesis is basically just a 3D model viewing application that was written by Rich. I don't know if he gives his real name in here or not. Yeah, Rich Whitehouse. Um, give him a Google. He's a really brilliant guy. Um, and his little viewer here is no different. It's a very brilliant viewer. It can do some crazy stuff. You can import some, or you can import a lot of different models from various different video games that he's reverse engineered, and you can even link up animations from a Connects, and you can actually walk around with a character of your choice. So it's just amazing what he's done, both with graphics, 3D and 2D and such like that in this application. Just phenomenal. Now, Noesis was later expanded. I don't know when he did it, but he allowed for a plugin system where users could supply Noesis with a Pantheon script that could import or export a model. So aside from the ones that he hard-coded into the actual application, you can add on to it whatever you want to add in terms of adding additional formats for reading different video games. So this makes it more open, more open platform, so that people can come and program to it. So that makes this such a more powerful viewing program. Now, what this comes in here is Chrrox has made a Noesis tutorial on how to create a Pantheon script to import a custom format or something like this. So this is a very advanced topic because you have to understand, I would say, hex editing, computer science, obviously. You have to understand some programming basics, and of course, willing to learn Pantheon and Noesis. So yeah, if you're in a position that where you have all those things, then you're ready to go. If you're coming from a clean slate, then this is going to be quite a long ride for you. So I would suggest going on YouTube, checking out some videos on basic computer science, hex editing. I think I have a video on that. I can attach it down below about MaxScript, not with Pantheon, but MaxScript. Also, you might want to look up some stuff on Pantheon. Now, I found this website here to be somewhat helpful. Over here, it has all the different things akin to Pantheon scripting and what it can do. So if I'm looking, okay, how do I do a loop? Oh, here, Pantheon loops. Great. Is there a for loop? Yeah, great. Is there a while loop? Awesome. So there are some basic necessities between programming languages, coming from Max. And I'm not a professional programmer, by the way. Chrrox actually was the one that got me into programming, period. He introduced me to MaxScript, and my skills came from him. So when I tried to do Pantheon today, again, Chrrox was a huge resource, huge help. He actually worked with me on Skype and got me going on this. So mad props to him, man. Hopefully I can do some more interesting things with this. Right now I'm just doing my baby steps. So this video is going to be the most fundamental, basic thing that I can share with you. I would say if you want more information, more detailed tutorial on that, Chrrox has an awesome tutorial here. It goes way into depth about importing materials and bones and weights. I didn't even touch that stuff. I just imported the plain geometry, so that's the simplest you can get. But we can get over some core concepts in this beginning video, I guess. Yes, quite nice. Okay, so with all that said, if you want to get started, you're going to need something to program a Pantheon script in. You do not have to download Pantheon. And even if you did download Pantheon, if you have Pantheon, there is no, I think, programming environment for it. So you're going to need some sort of script editor or something like this. MaxScript has its own script editor, and I like the script editor because it has color codes and brackets and stuff like that. So I was looking for an alternative solution to that. Now, I'm not sure if Chrrox recommends this in his tutorial, but he did tell me on Skype that he uses Notepad++, which is a open source, I guess, like script editor. And it does a whole host of different programming languages and script languages, so it's worth checking out. It's free. Now, personally, I didn't. I was too lazy to go and download it, so I just used CodeBlocks here. CodeBlocks is also free, and it seems to be, out of luck, compatible with Pantheon scripts. So it has the formattings that I needed that were similar to Mac scripts. So if you're interested in getting CodeBlocks, it has a dual purpose. You could program in other languages like C, if you're interested in that, or if you're already into that, maybe maybe an IDE you already own might work with Pantheon script. But I would say you would not want to work from a plain text pad or notepad. You would want to use something that will allow for formatting. Okay, so what I plan to do, I've already gone through the exercise with Chrrox online through Skype there. I think I'm comfortable enough to do it from scratch. So I'm going to start from scratch, delete this. We're going to do it from scratch, and I'm going to explain command by command why I'm doing this and all this stuff, so we get an idea of how we're going to do this from scratch. Now, there is a video I think I have on reversing files. I have a whole ton of them. I think I'll just link one in the description below. You can check out. But I'll give you a really quick run through of this one. This is just a file that was given to me, or some guy was making a request for the game Monopoly. It was really funny, but I was like, how easy is this format? So I downloaded it and I'm like, this is the easiest format ever. So I actually have another video where I do that Mac script. So definitely I'll link that below there. You can give that a check out if you want to. It shows how I figured everything out. But I'll give you a quick run through of that. Let me just get rid of all this junk here. Yeah, so all the color formattings. Okay, so basically what I usually do is I look for the basic components that I need. In the terms of a 3D model, you need the very basics of it, two components. You need the vertices that define the position and the object and its space, and then you have the polygons that make a triangle between 3 points, and that actually builds the surface of your objects. We're looking for vertex positions, and we're looking for a triangle list, or what I usually call as a faced list. So I usually start this by looking for a list, like a pattern, a list of repeating patterns, I suppose. So I usually just go like this in a section of the file. Usually it's at the top or the middle, and I just keep expanding the columns until I see everything line up. This one's actually kind of different, but I think it lines up around 56. So I think we're at 56 right now. Yeah. So we can see, it's hard to see, but we can see repeating patterns. We have 0, 0, 8, 0, BF, and that's repeated over and over again, that column there. So we have, in this hex editor, we have the hex in here, and we have the text over here on the right. So we can kind of look between the both of them and kind of see these patterns kind of form. And when we get to a certain position, I suppose, those patterns will change. And then we can say, oh, okay, so something has changed here, I guess. So I think, yeah, right around here, you'll see a difference in the pattern. So we see, on the text side, we see this jargon, which doesn't mean anything, but we can see these columns of these things repeating, right? We get to this spot here, roughly around here, and it's just a dead stop. So it's different, okay? And in fact, this is actually the polygons. It's a repeating list of 3 points, 3 indices that are defined in this list. And I just know this over just repeated attempts of trying to find stuff. You'll start to recognize the patterns more easily. So if I was to break this down in a notepad really easily, well, here, this is what I would usually do, is I would take this buffer size, which is roughly this, and I'd take the beginning of the buffer, which I think is roughly that. I'm not too accurate about it. So I have the beginning and the end of the buffer, and over here it tells me the size, which is D212. And so I can just look up at the header, is anything close to D212. And let's see here. Actually, what does D212 convert to? D212 in hex, from hex to dec, is actually around 53,000. So we can kind of bounce between here and look for a value that is close to 53,000. What am I now, right? Little Indian? Yeah, okay, so little Indian. Don't see anything. Okay, now what I'll do is maybe divide it by the stride, which we know is 56. And now we get something around 960. And so there actually was a count that was around 960. So we have this count, which is 971. So that's a candidate. We also have this one that's 956. Well, that one's pretty close. So this one we can maybe say is the count. Yeah. So the way it actually plotted out to be, I'll get the actual values here. This is the max script. And what I'll do is I'll color code them. Yes. Okay. So the first one was the vertex count, and the second one is the face count, actually. So let me just highlight this for you guys. And let me just double check here. Okay, so this is, and that is, actually that's wrong, isn't it? Oh no, okay, so that's, okay, so this is the vertex count. So I'll just color code this. You don't have to do this, I'm just color coding this so you can get an understanding of where everything is. Vertex count, and this will be the face count. Okay. Whatever, just whatever color there, and then where the buffer starts, I think it starts over around here. Why is that? Because we see these things that are integers, so this is an integer. But once we get past this, we get to this, and this is a very large integer, which doesn't make any sense. But ironically, it makes a float value. So if we go back, the float value is, to the power of negative 41. It doesn't make any sense. But this one actually makes sense as, negative 1 power. So that makes sense. So we probably start here. This is where we usually, what we can assume is where we start. So I'll mark that. Okay, so we know that we have to be in this column, which is the A column. We'll just scroll down to the bottom. Oh, or we could just do the math on it as well. So if we know this is the vertex count, so this is 971, so you just do the math on that. So 971 times 56. So that's your jump from that jump, or that offset, so we can go current position, and that should be where we're stuck at. So I'll highlight that. That's the vert buffer. Excuse me. And then this stuff here, I'm just going to skip over it because it contains a bunch of other information for the polygon. It might be a submaterial, so I don't really want to get into that. We'll skip it. You technically want to read it, but we'll skip it. And we'll go to the beginning of what looks like the... that's why I keep coughing. Just get drinks. The beginning of the face buffer. So I'm trying to guess where it begins. I think I guess that it begins. I guess maybe around here, I suppose. So we'd skip something around there. We'll just double check what I had done. What did I see here? So I skipped DC. Okay, so let me see that. DC. Okay, so that's where I actually determined it to start from. And that makes sense. It does. Because we start 1, 2, well, it's actually 0. 0, 1, 2, 3, 4, 5. So that's the typical way a face buffer will begin with, is 0, 1, 2, 3. Yeah. So we're going to skip this amount, DC, and then we would start from here, and that would actually be the face buffer. Now that count, we could still get the count here, so that's 596. So that would be, the stride is 2, because it's using shorts. You can see 1, 2, and it creates another number, 1, 2. So we got 956, was it? Times 2. And that would be in hexadecimal 778. So 778. No, that can't be right. Oh, okay. You know what? It must be times 3, because there's 3 points per triangle. And so that would be 1668. Okay, that makes more sense because we're ending at the end of that pattern. And I'll highlight that. Oh, man. Add whatever. Okay, so I've broken this down in the hex editor just so we have a clear understanding of the structures that we need to meet in the Pantheon script. I'm trying to correct this thing also. Okay, it looks about right now. I like it on a certain alignment. But anyway, so when I bring up the menu here, we can see... Oh, you know, I didn't name that. That's the face... Indices. How do you spell that? Indices? Indices? Indices buffer? Or is it index buffer? Index buffer? Or... Oh, whatever. Just call it the triangle. Triangle buffer. Yeah, whatever. So we can kind of get an idea of where we need to get to or where we need to go. Okay. So now we're going to start from scratch. Here's Noesis. So I just installed Noesis into the program folder. You can install it whatever you want. And you're going to go into plugins. And you know, I think I forgot to mention this, but you can actually make your own C plugins. The source is there. But anyway, Pantheon is easy to deal with. You can do it without a compiler. So it includes a install of Pantheon, so you don't have to install Pantheon. And then I think in here there was a bunch of other import scripts made by other people, or maybe example scripts made by him. I just moved these out. So I'm going to move... I already wrote this one, but I'm going to write it over again. I'm going to move this out of the directory. So what this means is I was able to import the model, but I'm not able to anymore. So I'm going to close this. I'll reopen it. And Monopoly was in the list, but it's not anymore. No. Okay, so we're going to write our own now. So we're basically going to use... ooh, yeah, you want to close it? Yeah. Close. No. Okay. So we're just going to create a new file in here. So we're going to go empty file. And we're going to save this as... oh, I keep coughing. Okay, so Pantheon. And we're going to save this. You can give it really any name you want to. But I kind of like the prefix format, FMT. And then we'll just call this the test one. Test one, whatever. We'll save that as a PY script, and then now we can begin to write it. Now, there's a template that is given to us by Rich, which is called the Noesis Pantheon example. I got way too many of these things open up, but anyway, this is going to give us an idea of, you know, everything we need to put in there. My only, I guess, criticism is that the comments are kind of poor. You get few comments, and it's hard to kind of piece together. But it goes through everything from A to Z. May that be, you know, adding skeleton or weights or whatever, error handling. All the examples are kind of here, and you can use that to pick apart to make a functional script. Now, go over the key pieces here, and we'll just copy paste pieces out of there and paste it into ours. So the pound sign acts as a comment, so those just to get ignored. You know, you could just put your name in there. It doesn't really matter. And we want to start with this one. So we're going to take this. And so what this does is it imports a bunch of... Is there no paste thing in here? Jesus. Control V. There we go. It imports a bunch of classes and functions from another script. So in the Pantheon folder, mind you, don't remove these. You need to keep those in there. There's a Pantheon script called include, or inc_Noesis. This one has a bunch of important libraries and stuff that you need to get this, or to get a model to import into Noesis. So, for example, I have it imported into here, and it's got a lot of classes and functions in it. So when we're including this, we're basically importing this. We're including all of these functions. It's as if you just copy this entire thing and you paste it in the top of your file. Okay. We'll get in more to these functions when they come up. So once we call this, we can actually, where is it? We can actually, this is actually, that you don't need. That's a redundancy. This thing import Noesis, it's in here. Import Noesis, import Rappy. So I don't know why that's in there. But anyway, so that doesn't have to be there. The first thing you need to do is you need to register your file with Noesis. I guess it's like the only thing that Noesis will look for is this function, or what they call definition, register Noesis type. So you have to have this exact function in there. So we're going to copy that. The comments say register Noesis types is called by Noesis to allow script to register formats. So let's say do not implement this function in script files unless you want them to be dedicated format modules. So I don't know what else you can use Pantheon for with Noesis, but apparently you can use it for other stuff. But you need to use this in our case because we're going to try and import a model binary file. Okay, this is kind of large. Okay, so we have the register Noesis types, and what it's doing is it's calling classes from the other py script that we can't see. Or, well, it's there, you can check it out, but we're using the import module called Noesis, which is over here, and we are using the class function called register, and it's just basically you import the comment and the extension of what you're working on. So the file that we're working on is HGS, and you can give this whatever name you want, but it's we'll just call it the test1 file, whatever, or we'll call it Monopoly. I guess that makes more sense. Whatever. And then you have these other ones, which in our case we're only going to be reading a model. We won't be writing a model, so I'll be deleting the write command ones, the write handler. So the only ones that are left are once you register it, excuse me, we're going to check the file we're going to verify that it's a legit file, and then if that passes, then we will be loading the file. And there's a comment here. It says see the other. What does that mean? Oh well, we'll just delete that comment. I don't know what that means. So the check type has to be run in order for this to load, or your model to be ran. So we do have to supply it with a function or a definition, I think they call them in Pantheon, a def that returns either true or false in this case, and that will allow you to load your model. And then you would apply a function that would do all the model loading into this function here. Okay, so, oh, you know what, what's this, print log can be useful for catching blah, 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 blah. Okay, this is another important thing that you can include in here, which is the console window. So I'm going to uncomment that, and we're going to run this script. So I'm going to save this, and you'll notice that once we run, or sorry, if we reload the plugins, oops, yeah, these don't exist yet. But let's just say we actually won't run it unless I have these right. Okay, let me just make some dummy definitions, or functions rather. Return 1, and darn it, fingers are all buttery. Okay, so these are just dummy functions, and they're encapsulated by their indentation. So you have to make sure you have proper indentation. So we're just gonna have like these dummy commands. They're gonna return true or good. I guess 1 means good, I guess. Just for now, just so I can show you the pop-up window. So I'm gonna run that again. So every time you make a save, or you save your your work with your Pantheon script, you're gonna want to reload it. So you have to go to Tools and reload it. Invalid syntax type definition. I see. Okay. You have to have brackets in there. My bad. That's kind of a simple thing. Alright, so try that again, and we should get that pop-up now. So that pop-up is created by this command here. And this is the console window, so once the console window is up, we can start to print things to it. So if I was to save and reload that with that turned off, it won't pop up. So if any of your Pantheon scripts includes this, it'll just keep popping up. So once you're done using it, you should always turn it off. But I guess we'll leave ours on so we can do some console printing. Now, I got ahead of myself, but we defined two functions in here to read into the handler, which is check type and load model. Now, you could leave it this way, for example, for the check type, if you had no way of checking the file somehow. I don't know how that's possible, but sometimes some files don't really have a type of definition that's easy to check to verify the file. Now, we do have a file ID, so we can actually do it. So in the example that Rich provides, we have this as, no, that's the wrong one, this thing as the example for checking the file type. So I'll just put this in here and we'll go through it. So length is getting the length of the file. So data is supposedly the file name that we got from, when we click on the file. That's fit into there. Length gets the file length, and it's saying if the file length is smaller than 8, because it looks like Rich was reading the header and the version number. So we're not going to do that. We're just going to read the 4 bytes. I'm going to worry about version. So 4 bytes would be the 1, 2, 3, 4, the HGS, or sorry, the HG3D. Okay. So he has these kind of constants in here. I'm not going to worry about that. So we're going to remove this one. So we're going to I don't know why he uses BS as the, because to me it's like saying bullshit, but I mean, I'm going to use F as my my file number for my bitstream. So Noesis bitstream is actually a another function inside of here, or sorry, class inside of here, which has a bunch of functions inside of the class, which you'll probably need. For example, you can get file size through here as well. You can write bytes, you can read bytes, you can get the cursor position, or you can, you can get the cursor position, or you can seek to a cursor position. So those are important functions. But anyway, so we've opened up the stream into F, and it's a class, so we can have other functions that come out of that. But we're going to supply, we're going to get the function from F, which is the read function, so that we can read from our stream. So we're going to go F read int. So int is actually 4 bytes. I'm going to use an unsigned int because I'm not really sure why he was using a signed int. And so you're saying if this does not equal, and then we're going to put in what it's supposed to equal. So 0x is going to represent a hexadecimal number, and I'm going to paste this in as a hexadecimal number. Now, because we're using little endian, I have to reverse the order. So instead of being 48473344, it would be 44334748. So we'll paste it in reversed order like this. And so we're saying if this does not equal what that's supposed to be, then you're going to return 0. Okay. Else return 1. Well, I mean, it'll complete without doing anything, and it'll return 1. All right. If the length okay, so if the length is too small, it'll fail. Yep. So this is just a type of error checking, or like error handling, I suppose, or whatever. It just checks type. So it'll check the type before it tries to read the file, and then it'll tell you if it failed or not. So we'll try to test this. For example, we'll go into here and reload the plugins. Okay. I probably typed it in wrong. Monopoly. Where is Monopoly? HGS. Yeah, okay, here it is. Check type takes no arguments, one given. Okay, let's see here. Where is it? CodeBlocks. I didn't give it any arguments. Oh, data must. Oops. Yeah, you have to supply it with data. My bad. So data has to be supplied because we have data in here. Yeah. That's probably in the example. Yeah, right here. That's my bad. We're also going to need data and model list in this one as well. I kind of screwed that up. So data will be the file name, in which case we'll have to open up the stream again. When this function exits, when it goes return 1 or return 0, the stream will be closed, so that's okay. But we'll be supplied the file name, and we'll be supplied with the scene, I guess, array, and we can add things into the array, which would be the scene. So this is actually Noesis's 3D viewer right here, and we'll put things into there later. So this should work now. Let's go back into here, reload, and double click. Yeah, so this is detected file type. I believe it failed, and I'll try to induce a fail. I'll just make this into a 0. And reload that. Start it. And we get an error. So now we have the detect file type is unknown. Okay. Just a really simple file check. Unfortunately, we have to have a function in there, but you can just leave it like that if you're not feeling like setting up some sort of file check. So we'll leave ours there. I have to correct that, obviously, otherwise it's not going to work. And now we're going to work on our model loading. So now all we have to do to get this thing to work is, I believe you append. Wait, how does it work? I think you go model list dot append, and then you append inside of here a Noesis py model or something like this, and then in there you supply it with a mesh. I think a Noesis mesh, Noesis py mesh, and that mesh must contain vertices, faces, etc. So you would construct it that way. So we should have in our example, there's going to be somewhere here, let's see here, model list. Yeah, okay. So we have that here. Okay, so we have model list append. We'll put the Noesis model, which will contain a mesh class, a bone class, and an animation class. I think that's an array of meshes, mesh classes and bone, whatever. So then we have to input these individual classes. So actually, no, I think these are arrays. Yeah, no, yes, they are arrays. So if we supply, for example, I typed this wrong. There's no py in there. Okay, we'll do it this way. So I'll paste this in here. And so this is a Noesis model, and we have to supply it with 3 arguments, which are basically just 3 arrays of various classes. So that would append a model if we had one, which we don't. The meshes, which is higher up here. Okay, that's also an array. Okay, so this is actually, yeah, I keep repeating that. It is an array, but yeah. So in the array, it would append. Where do they append it? Oh, mesh. Okay, so mesh comes from mesh is right here. Yeah, so it says Noesis mesh, and then you supply it with this stuff. So that's an example of that, and we can just paste that into there. The square brackets represent an array, which it was supposed to be appended into. So how do I paste in this program? There we go. So this line will operate correctly for us. We're just missing the bones and the animations, which should be okay. Now we have to focus in on the actual mesh. So we have to supply it with a, I guess like a face list, a position list, a mesh name, and a material name. So we're not going to deal with materials today or anything like that. In the file, I actually seen a name in there past the vertices, and I don't know if that's a material name. It says token car. So I'm not going to worry about being fancy. So we're just going to skip this out. So we can just say whatever, say name. No, mesh 1, mesh 0, and mat 0, whatever. So now it's super simple. You basically just apply it with an index list and a position list. Now, what I found was, I guess, kind of easier to do is, because I mean, you can only supply it with this or this, and I don't think you can supply it with anything else. So it's easier if you make this a, whatchamacallit, a variable. So what I would do is I would go mesh equals my Noesis thingy, and then mesh would go into there. And then this I would just leave as, well, you can put it in there, but I would just leave that as an empty array. And then you can just use the add commands. So if you go and you look for this inside of your included script, yeah, okay, so yeah, here it is, Noesis. No, that's not it. I want Noesis mesh. Noesis mesh. Where is it? Animations. Okay. Okay, it's kind of messed up. Let's go to the top here. What's this thing? Wrapper. That doesn't work. Okay, how do I go? Auto wrap. Find in files. Multi-line search. Oh. Regular expression. What does that mean? From cursor. Do I have to do that like every time? Okay, sorry. Where is it? Oh man. That's material, that's texture. Quadration, more quadration. Okay, is this matrices? I'm really far off. Let's go to the top here. This is unpacker, bitstream. This is vectors, angles, mats, more mat. Oh, that's matrices bone, keyframe bone, keyframe animation, procedural animation, user stream. There you go. Damn it, it was way down there. Okay, sorry. So these functions are the ones you can use to basically add stuff. So we can add faces, we can set the materials, set positions, set normals, and set UVs, and so forth, so forth. Because I think the arguments that you pass into it, you can only pass in so many of them. So if you want to do more stuff, you'd have to go the router that way. So how you would do that then is, for example, we go mesh dot, and then whatever function we want to bring up. So, for example, what we were doing before is supplying it with the argument indices and then positions. So we can just go like this. So set indices, and we put our array inside of there, and then same thing, the positions. Positions. No. That's why I always copy and paste, because I'm really prone to making spelling mistakes. It's really sad. Yeah. Anyways, we don't have anything in an array right now, but that's basically the core setup of how this would work. So when Noesis runs, it'll register, send the handles, it'll verify that you can run it, ask for the checking thing, and then run your load operation or your load function. Goes down your load function, and basically you just want to append anything that's a model to your model list by way of creating a mesh with the Noesis mesh functions, and you can do it in a couple ways actually, but this way I'm going to be showing you is I think a little more easier, more relatable to MaxScript. The way that Chrrox showed me was using Rappy, so we're not actually using Rappy, but maybe I'll do that in a different video. So yeah, so what we want to do is basically just fill these with stuff. Now I think if I run this, we won't get anything. Maybe throw an error. Let's see what happens. It might just create a blank object. Yeah. Vertex position list is empty, ignoring the mesh. So this is basically a template that you would want to start with, and then add on to it as you expand your knowledge, I would say. Fortunately, the template we get is like really complicated, but I mean, Rich did a really good job with everything he did. It's just I'm not smart enough for this stuff. I'm like really dumb. So this is the stripped down version. Now we want to implement our reading or parsing of this file. It would be really simple. The reason why I summarize this in this list here is basically what we want to do is get the vertex count, get the face count, go to the vertex buffer, read it how many times by the vertex count, then travel to the face or the faces or the triangles, and then you're going to read it per how many faces. I just want to boil it down as simple as possible. So now what we're going to do is, because we haven't opened the file yet, we're going to make, we're either going to do it in here, or you can make it in another function. It's totally up to you. Personally, I like to use structs, for example. In here I use a structure, which is, I guess, in here considered a class. So I'll do that as if I was going to make a class. Okay, so we'll say class HGS format. Okay. Then we're going to put in our definition for our initialization and arguments. I don't think, yeah, you have to have one argument. That's the actual. So self just means, hey, I'm myself. Does that make any sense? No, with this class, right? You have to tell this function that it's inside and it's going to modify itself. It's the logic didn't make any sense to me either. Oh yeah, I can't do. It's not brackets in this one. And then you would put your initialization, I think, in here. So we would want two things. We would want the vertex count. Sorry, I did this wrong. I had to go self. So self thing is kind of dumb. Self, and then we're going to initialize it to 0. And then again, self dot face count equals 0. Okay. That should initialize it. And now if we want to read stuff into those, we're going to make another one. Now you can actually go into here and actually just go, let's say for example, like read f dot read int something, and actually retrieve it directly. But in my mind personally, I would create this array, and then I would have two functions, one that reads and one that writes. But I haven't gotten into writing yet, so I'm just prepping this in the context that I would later on add a write function. But anyway, so we're going to read from file. Actually, I should probably capitalize that, read from file, so that's more, yeah. Self, and then we're going to give it the file stream. Okay. Oh, I keep doing that because I've used MaxRip for so long. Now we're going to have to open the stream somehow. We can either open it up in the class. Where am I? But I'm going to open it up through here, I think. So go f equals, and we use the open stream in here. So we're just going to copy that. Okay, so we've got that in there. And now I'm going to basically create my class. So I'm going to create HGS equals my class. And by doing it this way, it will automatically initialize the initialization function, and these will now have these starting values. And then I'm going to do this. I'm going to go HGS. Oh man, I'm terrible at writing. Dot read. Yeah, read from file. Now we have to supply it with just one thing actually. The self thing is sort of ignored, I think. You just supply it with f. So another way you could do this expression is just put this directly into there. Yeah, actually that would work too. But I'll just leave it like this because it's a little more simpler. So now that file stream will open up at the beginning again because we closed it in the last function, and we've reopened it here. So we're now at the position 0. But we might want to set the position later on in there just in case. So now we're inside of here because we're calling the read file function right after. Whoa, my bad, did that by accident. We're going to do some stuff. So we're going to fill this array. So we're going to go to my listing again. So we need to go to position 26, get the vertex count, and then go to position 2a. So we can actually read those one after another after we go to position 26. So what we're going to do is we're going to go to f. So we're going to use f dot seek, and then in brackets. Now this function comes from over here, and man, where is it? There it is. Okay, so seek is down here. Seek you have to supply with, remember you ignored the self, so it's the address and then is it relative or not. So I thought this was bool, but it's actually no seek ABS means Noesis seek absolute, and that variable is actually a constant that's defined here. So you could set 0 for absolute and 1 for relative, or you can just use these constants, I think. So we're going to be moving absolute. So we're going to type in, well, we're working hexadecimal right now, so it's going to be 0x26, comma, no seek absolute. So that will go to 26. Okay. Now we're going to go and read our thingamabobby. So basically that equals f. We're going to call up another function from that class, and that's going to be read u int, and in brackets. Okay, this one again comes from here, and these ones are a little more simpler. You don't have to provide any, like, well, maybe you do. No, no, there's nothing. It's just self. Yeah, so you have different ones in there. I won't get into the different data types because there's some nice ones supported in here, but there's a lot of different data types. But that's a topic for another video. We'll get to that later. So that's going to read the 4 bytes, which is the count, and we'll just directly read the face count after that. Great. Now we're going to move down to the buffer position, which would be at our buffer position is at 42. And we're going to have to create a loop, and we're going to have to create an array to put that loop into. So we could put our array, I guess, in here. Self dot vert array equals an array, and then we'll do face array that way. Okay, so now that we're here, we're going to create a loop. So that's a loop for Pantheon. You can look that up in here. Okay, so we're gonna want a for loop. So loops, and then we're doing a for loop. It's gonna explain that is for a variable in seq. This is actually a really bad way. Here we go. This is actually this is still a really bad practical example. This is a super bad practical example. Okay, this is the example this is the practical example that you should have. So here I'll just type it up for you. This is stupid. So for I in range, and then you give it the range, so it would be from 0 to the count. So we're gonna go self dot. This is, you know what? I typed that in wrong. Whoops. Vertex or vertex count. Yep. And sorry. We're going to do some stuff, right? Of course. Now this is a situation where we have to make sure we read from one line and then move to the next line over and over again. So to do that, you can do some math. You don't actually need this here. We can actually move this down into here. And the math is as such it would be plus I times the stride. So the stride is 56. I believe it was 56. Could be wrong. And so what that means is when we had stretched out these columns, there was an alignment where things all aligned at the stride of 56. Okay, there wasn't a value defined there, but we had just figured that out. So that may be dynamic, that may be static, but we're going to use that as a static for now. So this is going to say 42 plus, I think I have to bracket this actually, my bad. This should be in a bracket. Oh, this thing is screwing me up, okay. It's like, okay, fine. Do it that way. Okay, so it's saying, so you're taking the base address of 42 plus, and I will start at 0, and it will be times 56, and that'll be 0. So that'll be, the first one will be at the base address, and the next one will be at the next increment, so forth and so forth. So, oh, wait a minute, what's going on in my brackets here? That's not supposed to be there. So now we can start to do, now that we're at the proper line in that buffer, we can now do some stuff. So we're going to want to read in the vertices. Now this is the weird thing that I encountered, is that the vertices have to be represented as a special Noesis file type or data type, which I found kind of odd, but the data type is the Noesis vector3, and you have to use that class apparently. So that class is explained here. You basically just apply it with this. So we'll go like, oh, do we have to set the size of this thing? Oh yeah, I think we have to set the size of this thing. So what we'll do is we'll just initialize those there. So this will be Noesis vector3 in brackets times, and then how many times we're gonna, oh, I did this in the wrong one, my bad. It's supposed to be here. Sorry. So this is going to be by the count. So we can take this times the count, and that will make the array size apparently. It's kind of weird, but apparently what it's supposed to do. And then down in here, what I would do is access the array with our index number I, and then go equals, and then supply it with the the vector3. And inside the vector3, we have to supply it with this, basically. And that goes inside of there. Now, these zeros, we want to replace that with a read function. So what that would be is f dot read. This is, in this case, is a float. Now, I'm not sure if that's actually the read name or the actual function name for that. Let me just double check, 'cause I could be wrong. Read float. Yeah, okay, that is it. So read float, and we're just going to do that a ton of times. So just 3 times. So you need that for x, y, and z. So that's why there's 3 of them. We put that into the array. No problem. There's some other stuff in there. We're just going to skip it. There's like normals, binormals, tangents, UVs. Who needs that, right? No, this video is going to be long enough, so I won't get into anything more than this. So this will just give us the position so that we can build the actual object, but we won't get into other stuff for now. So now we want to collect the faces. Now for me, this is what was weird. In 3ds Max, you supply the faces in pairs of 3. So you have, you know, a triangle is, you know, 3 points. So you supply them in groups of 3. But in this one, you don't. You just supply the array as a chain or a stream of indices, and then Noesis will interpret those based on how you define those. So I need to take the count, and I need to times this by the count times 3 because of how that's made. But now we should be able just to do this. Now, before I get ahead of myself, between the vertex buffer and the face buffer, there was some extra stuff that I did not bother figuring out. So what I'm going to do is I'm just going to move the cursor DC, which is that space there, just to get to the next buffer, because I don't want to deal with this right now. So we'll just put a little fseek in there. That was stupid thing. Times DC. Then supposed to be relative. Okay, so we're going to seek, and that will bring us to the position where the face buffer is supposedly supposed to be. We go by face count times 3, and we just basically read that into the face buffer. So we go self.face array brackets I equals, and this is these are short values now, so we'll do this. Read u short. I think you're supposed to actually read a sign short, but we'll just do this for now, because I can't quite remember. Okay, that's it. So I gotta make sure my indentation is correct. Let me just double check. So we jump to the header address for the counts. We grab them. We use those counts to initialize our arrays. Then we create a loop, and we read those. We read that data into the array. Vertices are done. Then we skip. Okay, that's what I did. This is actually supposed to be outside of the loop there. I don't like the way this works, but you have to use indentation to get this stuff proper. So that's right. And now we should have inside of our structure, keep saying structure, class, 2 arrays which we can feed into here. So we can go like, wait, where is it? Oh, this thing up here. So we can go like this. So we go HG, yes, HGS? No, yeah. Ooh, spelled that totally backwards. HGS dot vert array, is that what I said? Yeah, vert array. Oh, I got that backwards. Darn it. Okay, put this one over here. This is faces, or what do I call it? Face array, not vert face. What the heck? Yeah, I'm tired. Okay, so face array, and then that should be it. So create the mesh, and that feeds into there. Yeah, that should work. So I'm going to save that, and that should work. So let's give that a go. We might get some errors because I'm still new at this, but see how it goes. Okay, so we get an error with the read of the face. It says in this line, wait, no bitstream object, no attribute. Oh, okay, that's weird. Okay, let me just double check. Saying that I used the wrong read command. Must be like case sensitive or something like this. That sucks. Where am I going? Okay, so read float, redouble, read u short. Yeah, it must be case sensitive. So we're going to place that there. Save. Tools, reload. Okay, no errors. Now we got an error. Out of index range. Okay, so we read this, but we went out of range. That's odd. No. Let me just double check. So I initialized it here. So we go the count times 3. Maybe I have to do this. Does that matter? I'm not really good at math. Do I have to put those in brackets? Times that. This one is times that. Okay, let's try that again. Tools, reload. Click. No, so this is the same thing. List or assignment index out of range. Nope. So that means that this I went out of range. So face count times 3. Face count times 3. Face array. Face array. No, that should work. Huh. Am I using this correctly? F read short. Seek relative position. Relative, yeah. So it's relative, goes DC from where it ended. And just double check this. DC. Yep, puts me here at the beginning of the face array. Reads in parts of 2. Unless I'm off by 1. No, DC, that's right. Unless I move to the... Yeah, maybe I moved to the face buffer wrong. Yeah, that's probably what I did wrong. Okay, so I'm not at the face buffer, perhaps. So the face buffer starts at 42. So I'm going to set this for 42. Absolute, so that we're absolutely sure that we're at the face buffer. I'm going to try that again, and reload. No errors. Double click. Same error. Okay, maybe it's a different error. Line 45, nope. Line 38 from self face array equals read short. Index error. List assignment index out of range. Let's see here. Just double check here. Is it really this thing, maybe? I don't think it's a... I thought it was a base of 0. Pretty sure it's a base of 0. No, what am I doing? It's this thing I'm looking at. So this is I0 to face count. Face count. Maybe it's not actually times 3. Okay. Try this again. Tools reload. Okay, it's totally something different. List arrange assignment index out of range. Okay, so we face array. Face array equals... Oh, is that what it is? I didn't initialize it, maybe. No. Can't be right. No. Load. Oh, that was it. Okay. Oh, man. That didn't even make any sense. Okay, so you know what? I think it still is times 3, if I remember correctly. But this thing I forgot to initialize, apparently. That gave me all sorts of weird errors about the index being out of range. That didn't make any sense. Now, it loaded an empty file, I think. Let me try that again. Oh, mesh index count divisible by 3. Ignoring. That's interesting. Okay, I'm going to clear the window here. Reload. Mesh contains an out-of-range triangle index, discarding the object, or mesh. Okay, so this is, what this is meaning, or what this is saying to us, is that, let's say we have like 3 vertices, right? And our triangle list says, it's supposed to say 1, 2, 3, or rather 0, 1, 2, but it might be saying 10, 11, 13, or something like that. That means we're out of range. So this could be from a couple things. I could be the wrong position or something like this. Now, I'm pretty sure I is a base of 0, but if it was a base of 1, then we would be off by 1. That would mean that would be pushed off by 1, and then in that case we would be in the wrong spot. So we're going to do a print just to double check. So print offset offset I think it's H. I could be wrong about that. I'm definitely wrong about that. We'll just go like this, this, and then in the bracket. And I always forget to do the other bracket here. This is going to be f.tell. Just double check this. Bracket around there, goes into there. New line, save. And we're going to run that. So we're going to go Tools, Reload Plugin. What? Unsupported format character OXA. What? Confused. Print offset at index 9 unsupported format character question mark. Well, I maybe misunderstood how the format printer works. I thought that's the way it worked, but I could be wrong. we'll just do this instead. This will make it easier. I'll just print directly the spot. Yeah. Keep going to the wrong spot. Yeah. No. Do that one more time. Okay, so yeah, it fails. So it says that we're here. So we switch this in the decimal. Beginning of the file, and we are in the wrong spot. Wow, okay. So that is 44. Why am I off by 44? That's weird. Dude, that's weird. Okay, so I'm going to 42. That seems correct. And my stride is 56. So just double check this. So 42 in hex, and I'm going by 56. So this just, I don't know. Seems to be wrong. So ftel, this is definitely off. Ah, yeah, that's right, because, yeah, that's right. Yeah, I goofed. I totally goofed. Okay, so this address has to be corrected. That's what it is. I mean, this one over here. So it would be the base address, which we'd have to calculate by doing this. So 42 times. Oh, I did it wrong. 56 by the count plus DC, and that should work now. So let me just grab this, put this here, and we'll just test it. Tool reload plugin. Oh wow, that's terrible. No, okay. Wow, where do I begin? Okay, I screwed something up around here. Okay, so we fseek. So we got. Yeah, so get rid of this, I guess. So it's 42 plus, in brackets we have times 56 plus DC, we did the print there. Okay, so I corrected the indentation. Okay, it should work. So just type in clear to clear that, because that's hard to see what's going on. Reload the plugins. Boot it. Okay, so we got. Try to set the offset beyond the buffer size. So the amount that we got here is too large. Wow. Why would it be too large? Actually, that should actually be the same thing. Oh, nope. ABS. This actually might be +1. Yeah. Okay, let's try that. Save, and hopefully it works this time. It's been pretty bad. Okay. Kind of anticlimactic. It just worked. Okay, so I think that's right. So we get rid of this. I can use this to verify where we actually landed. So I can go into decimal again. Go to absolute, and we are at the face buffer. Okay, so that's correct. Sorry, I got confused with all the positional stuff. So now we're at the correct spot. Let's try that again. So clear and load. Okay, so the material failed because we don't have one, but that's okay. So let's see here. Can I just close that? Or maybe I can't. Yeah, I'll just leave it open. So yeah, we feed that through there. So the only point I was going to make is you would do other stuff in here, but if this wasn't the intent, then you can actually simplify it. Yeah, I don't think you would actually do that because the model just having faces and vertices isn't enough. You need UVs and stuff like that. But I think you can streamline it by putting this array directly into here, and this array directly into there, and then you can just do it like that. We'll put that into the brackets that way, and so that would be your build function. So if I reload this, it would load up. So close, open. That stupid box is still there. You might want to get rid of that dumb box. So to do that, you would want to go up here and flag that out. The pound sign, if I can find the pound sign on my keyboard. Reopen. And yeah, it should just like auto load. Beautiful, beautiful, beautiful. Cool. The power of Noesis is in your hands now. Awesome. Okay. Sorry that took so long. I'm still learning this myself, and I don't know. I should have known better than that, but I mean, oh well. Mistakes happen, and you have to learn to debug and work with print functions and stuff like that, so forth and so forth. Now, Chrrox showed me another way of doing this with Rappy. Rappy is described in here. You can go through that if you wish. I believe that Chrrox's full tutorial goes through using Rappy. So I'm using an alternative way of doing it, I guess. But I prefer doing it this way until I'm more comfortable with the more advanced stuff that Noesis can do. So yeah, so that's how to load basic mesh into Noesis and program your own Pantheon script. Of course, if you have any questions, ask on the Zentex forums. Chris is usually on there, or Chrrox is usually on there. You can probably answer you within a couple days. If not, I'll get you right away. So check out his tutorial. Check out Rich's site, Senor Cascaraga. I don't even know what that means. If you need help, check out the Pantheon stuff. And yeah. Okay, thanks for watching, guys. Take care. Have a good night, and good luck with your coding projects. Okay, later.